Can you unmute me? Good morning and welcome to the Science Oxford Winter Wonders live stream. We asked you a question while you're waiting, so I know we've got at least one response. So if anyone else has got any other answers to the question of how you would describe snow to an alien that's never seen it, if you post them now, I'll be able to respond to you in a moment. My name is Ian. I'm going to be presenting a few of our favourite wintry science demonstrations this morning. My glamorous assistant Daniel will be helping with some of the equipment, and behind the scenes I have the fantastic Emily and Sarah who are dealing with the technical side of things. So they'll be making sure this is going to YouTube and dealing with any of your comments in the live chat. As mentioned, we asked you a question while you were waiting. I will be asking you more questions during the show. And if you have any questions of your own or anything interesting to add, if you talk to your teacher, if you tell your teacher something, then they can post it in the live chat and we can bring it up on screen and respond to what you're having to say. There's going to be several opportunities for you to discuss things and answer questions. When we give you the time to do that, please have a conversation in your class. Talk about what you've been looking at. Tell your teacher your interesting things. And teachers, if you do post things in the live chat, if it's not obvious from your YouTube username, please do post the name of your school, maybe your class name, and possibly even the name of any child that said anything particularly insightful, so that we can make sure that they get the recognition they deserve. Now, I've got a list of some schools that I know have said they're going to be joining us today, and I think there may well be some others as well. I know we've got All Saints School, we have Aston Rowant, Church of England Primary, we've got Barton Park, we have Burford Primary, we have Cuddington and Dinton, we have Headington Prep, we have Lady Grove Park, we have Oakley, we have Our Lady of Lourdes Catholic Primary, we have Sandhill School, we have St Joseph's Catholic Primary School, we have Wantage Church of England, and we have Wolvercut Primary School. There may be some more as well that have mentioned something that they're here and haven't told us in advance. But welcome, everyone. I'm really glad you could join us. So with all the introductions done, let's go back to that question that we asked as you were waiting. How would you describe snow to an alien who's never seen it? Now, I can see Wolvercut Primary School saying it only appears in autumn and winter. And that's a really good point. That's why we've made it part of our winter wonders. It's cold and wet and squashy. It's fun to play with. It can break easy. It can be hard and soft. Now, you may have noticed I have here a plate of snow. So let's see how some of that description matches what we've got here. So I've got something, it's certainly white. It's quite soft. One of the descriptions was it was soft. It's squashy. But what I can say with this is it's not very cold. And it doesn't feel wet to me. If I just come around here and I get some in my hand, one of the things I can see is it's not melting, it's not wet, it's not forming any water in my hand, and it's not feeling cold. Now, the reason snow is cold and wet is because actually snow is a type of ice. It's formed when the weather outside is cold enough for rain to actually freeze as it's falling down in the sky. So it's tiny bits of ice that are landing on the ground, so small that it often feels soft. It's soft because they're really small bits of ice. So I've got here some crushed ice. I'm just going to compare that. I'm going to put some of this in my hand and just show you here on the camera that this is glistening, it's melting. There is water forming there on my hand. This is sliding around. This definitely is cold. So ice is cold and wet, whereas my snow is not. It is white, it is fluffy, it is squashy, but it's not cold and wet. So this isn't really matching your description of snow there. And I'll let you on a secret. This is fake snow. Daniel and I made this earlier, and I was going to make some more directly on camera, but I have a slight problem because I mixed up our fake snow powder. I put some out, got it ready, and I've mixed it up with some other different white powders. So unfortunately, I can't tell them apart. Here I have 3 different white powders, and they look very, very similar to me. They are all fine white powders in these little Petri dishes. They're all white, small grains, they're rattling around. They all look and feel very, very similar. Now, I happen to know one of them is sand, one of them is sugar, and one of them is our fake snow powder. Now, in a moment, I'm going to add some water to each of those, and hopefully that will let us figure out which one is the fake snow. So I'm just going to give you an opportunity to have a chat in your class, and I want you to talk to each other. What do you think each of those different powders is going to do when we add water to them? Remember, one is sand, one is sugar, and one is our fake snow. What's going to happen when we add water? How will I be able to tell them apart? I'm going to give you a couple of minutes to discuss that. Okay, so off you go. And welcome back. So thank you for that. I can see we've got a few different answers are coming in. So I can see the first one coming in from Miss Young's class, I believe. I think that's All Saints School. They said, I think the sand will go wet, soggy, and mushy. It will all stick together. Right. I can see there's various other things that come through as well, but let's just try our first powder. And I've got our first powder here. Let's see what this might be. I'm going to pour some water in. And so not much really is happening here. I've got the powder's, it has kind of gone stuck together. It's gone a bit mushy. I think this might be the sand because that is matching the description there from someone in Miss Young's class. So someone in Miss Atkins' class has said that they think the sand will turn a darker color. So I think maybe this has turned a little bit darker. It's not easy to see on camera. There's a lot of glare coming off it because it's very white sand, but I think this is a little bit darker than it was to start off with from me here in person. So I think that one must be the sand. So let's have a look at our second powder. And I'm going to add a bit of water to this one. Oops. And I can see there that, in fact, already this powder seems to be disappearing. If I give it a stir, it has all gone. This powder has completely disappeared. Well, I think we can tell this one's definitely not the fake snow. And we know it can't really be sand because sand doesn't disappear because we can see sand at the beach all the time. When the sea comes in, the sand doesn't disappear. So this has disappeared. In fact, actually, the word we use for that is dissolved. We add water to sugar and the sugar dissolves, and that means it's broken down into its smallest possible parts, and all the sugar has been completely spread out through the liquid. Now we know it's still there. If I were to taste that, it would still taste sweet, but the sugar has dissolved. So that one must be our sugar, which means we have one left. So hopefully this means this must be the snow powder. Now I can see Chloe has said she thinks the snow powder will expand because it's going to soak up the water and get bigger. Now let's see if Chloe is right. So as I add the water in, what we can see there, what started as a small amount of powder at the bottom has indeed expanded. If I put it on its side, you can see how it's spread up the side of the dish there. Let me see if I can add a bit more water, if it can just soak up, if it can absorb any more. There we go. It's absorbed even more water. And it's expanded. It's got really big. And it's made a whole dish full of fake snow there. And I can see that's quite mushy and soft. But it's definitely expanded. So that is how we made our fake snow. So all this talk about snow is making me feel really cold. So when it gets cold like this in the winter, the nights draw and it starts getting really dark. And all I really want to do is just curl up under a blanket with a good book, maybe a nice warm drink, and maybe even just read my book under the candlelight. Makes me feel nice and warm. So I have a candle over here. And I'm just going to bring this forward and light the candle for you. Because I want you to get a really good look at this candle burning. There we go. So I have this candle here, just I've lit it and you can see the flame burning there. And I want you to just watch this candle really carefully. I want you to have another discussion in your class. I want you to talk to each other about what you think is going on when a candle's burning. What does a fire like this need to burn, for example? Maybe you can tell me what you can see, what you can hear, what you've experienced before when you've watched candles burning. Maybe you can think about what the fire needs. Maybe you could think about how you might go about putting out a candle and how that works. So anything you find interesting about candles and small fires like this, if you have that discussion, talk to your teacher, and we'll come back to you in a few minutes. And welcome back. So we've had some brilliant answers. I can already see one we're going to start with Issy from Hedgehog's class. Has said the hot flame is melting the wax. Now, if you watch really carefully on the picture, you may see some wax sort of dripping down the side. You can see this candle's quite misshapen, where various bits of wax have melted off. And yeah, Miss Young's class said the same thing. The candle's going to get smaller and smaller because it will melt. I have here another candle. This is a birthday candle, very small. I'm just going to show you that indeed that is exactly what happens. If I take this candle and put it directly in the hot flame here, what you can see is that that wax is melting and dripping down. But you can see this small candle by itself is not actually burning. The wax is certainly melting. This candle is definitely getting smaller, but it hasn't burnt by itself. The wax on its own melts from the heat. It doesn't actually burn. So I think Headington Prep said that it needs the wick and the wax to burn. So the candle needs the wick and the wax to burn. I've got here just an ordinary candle wick. If I take the candle wick itself and I place that in the flame, the wick does burn, but you can see it's burning it does burn as well, but it's burning relatively quickly. And it's burning through that wick quite quickly. So I'm going to put that out now. So the wick by itself will burn, but it won't last very long. And we need the wick and the wax together to enable it to burn. If I take my birthday candle again, if I just put the end of the wick into the flame and light it, then indeed the birthday candle is now burning completely. And what's happening there is the hot flame is melting the wax, but that wax is then soaking into the wick, being brought up to the top, where it's then burning. Now, various other people also mentioned that we need a spark. We need some kind of source of heat to enable the fire to start as well. Thanks, water voles, for example. And so when the heat from an existing flame, for example, reaches the wick on the birthday candle, it starts that flame where it melts the wax and it turns the wax into fuel. Another class mentioned that it needs air, but not too much. And so it might need wind, but not too much, maybe air. And absolutely right, it needs air to be able to burn, but not too much. If I can blow a candle out by giving it too much air, like so. What's actually happening there is when I blow hard enough, it actually gets really cold. You can simulate this yourself by blowing on the back of your hand. You can feel that it's cold, and that's there taking the heat out of the flame and cooling it down. But we absolutely do need air, and I can demonstrate that by just, if I cover over the candle flame with this glass, then I am stopping air from getting to the flame. And you can see it goes out. And so by preventing air from getting to the candle flame, then it stops burning. Now, there's one other interesting thing we can demonstrate with a candle flame. And that's, we mentioned that the wax is soaking into the wick and it's burning, and it's soaking into it, coming up to the top, and it's burning off. Now, we can actually watch this happen. If I relight my candle, Daniel's going to come and assist me. What I'm going to do is I'm going to blow the candle out, and Daniel's going to try and relight it with the lighter, but we're not going to bring the lighter all the way down to the wick. So watch really carefully as I blow this out. You can see there's a lot of smoke coming off. And that smoke you saw there is actually the wax. It's the wax is evaporating. It's turning into wax vapor. And that wax vapor is floating up and enabling you to see it as smoke. And what you may have seen there is that the flame relights the wax vapor, and the flame then jumps back down that trail of wax vapor back to the wick. So you can see there that the wax is coming out as a gas, and that's what's burning. And when we blow it out, then it's putting it out, but we can relight that wax vapor. I'm going to show you a slow motion video of the same thing so you can see it in a little bit more detail. What am I doing? I'm taking this away, aren't I? Taking this away. Shit. Okay, and welcome back. So I have something else to show you now. Oh, thanks, Miss Atkins' class. I think it's very cool. I agree. That's why we showed you the slow motion video, because I think it really does highlight exactly what's going on. I've got something else to show you now, and one other thing that makes us able to survive the cold of winter, makes it a bit more fun, is when we have some nice cool drinks, maybe hot drinks like hot chocolate or something kind of funky. And I'm going to try and make a drink for you now out of stuff I've got lying around in my kitchen. So I've got myself a nice big pint glass to make myself the drink. And our first ingredient is going to be some golden syrup. Something nice and thick and gloopy, very sweet, to give us an excellent base for our drink. I'm going to pour this into our glass. You can see it's very, very thick there at the bottom of our glass. Let's move this a bit forward to get a better view of it. Oh, no, there we go. There. Squeeze that in. So we have there our nice thick layer of golden syrup in the bottom of our glass. Very thick, very sticky. Next ingredient, we have some washing up liquid. Maybe I won't actually be drinking this, but at least it'll make it easier to clean up later. And I'm going to try, again, this is very thick, not quite as sticky as our golden syrup. And what I'm going to do, I'm going to be really careful, because what I don't want is for these to mix. I want you to watch really carefully. I pour this down the side of the glass. What you can see, if I'm really careful, they don't mix. And instead, my washing up liquid sits as a layer on top of the golden syrup. So I want about the same amount of this. There we go. You can see a little bit there spilling down into the bottom there, but there, it's sitting on top. So we've now got two layers. We've got to have a golden layer and a green layer. Right, next up, I have something you definitely can drink, just some ordinary water now. And I'm going to pour this on top. Now, you probably know normally if we add washing up liquid and water together, we get lots of bubbles. But I don't want lots of bubbles today. So I'm going to be really, really careful and pour this really slowly. And again, if I'm really careful, then hopefully the two liquids won't mix together and I can get another layer on top. This one's the tricky one, because we do know that washing up liquid and water really do like to mix together. So I have to be very, very careful when I'm doing this. But there we go. We have a layer of water on top of the washing up liquid. There's been a little bit of mixing there at the bottom. You can see we've got some green swirls, but it's mostly stayed separate. I've got one final layer to add, and that is some oil. So some ordinary vegetable oil. I'm going to add this to the top. Now, you probably know that oil and water don't mix. You've possibly seen this before. So again, I'm going to try and be careful, but we should be able to get the oil as another layer on the top. Now, obviously, this is something I could drink, but I really probably shouldn't. There's lots and lots of oil. That's way too much oil to be drinking. You shouldn't drink oil directly anyway. You can cook with a little bit of it, but actually drinking it directly, very bad idea. So there we have 4 layers, a lovely 4-layer drink. Now, obviously, I wouldn't really be drinking this. If we hadn't put the washing up liquid in there, we could in principle, but it's not something I really want to be drinking. But I want to show you some really interesting things about this, because I've made this 4-layer liquid, but I want to now show you some strange properties. I'm going to try dropping some things into it. I have, first of all here, I have a stone. And I'm going to drop this stone into my glass, and we're going to see what happens. I just want you to have a quick think to yourself, think in your head, what's going to happen when I drop the stone in? I'm not going to have time to respond to any live chat comments, so just think to yourself. And 3, 2, 1. There. The stone sinks to the bottom. Now, you probably predicted that, where most people are aware that stones will sink. You may have noticed it was quite slow going through the golden syrup at the bottom there. As I said, it's very, very thick and gloopy. Because a stone is heavy and it sinks to the bottom of the glass. Next up, I've got a polystyrene ball. Now, polystyrene is a very soft plastic that's got lots of air in it. If you've ever looked closely at polystyrene, if you've seen it, you may see that it's got kind of looks like it's made of tiny little white balls, and each of those is full of air. So what do you think might happen to this? It's very, very light. What might happen to this? Again, have a think in your head. What's going to happen when I drop the polystyrene ball in this glass? 3, 2, 1. It just sits right on the top. It's floating there on the top because it's so light, it floats right on the top there of the oil. Now for something a little bit different. I have my festive fruit platter. I'm going to try dropping some various fruits in. The first fruit I have is a date. And dates are quite sticky. They're chewy fruit. They've actually got a stone in, so they're quite heavy. So when I drop this in, again, I want you to think to yourself, what's going to happen? Let's watch and find out. 3, 2, 1. And the date drops down, and you may just be able to see it's quite dark, but it's there, sitting on the top of the golden syrup in the washing up liquid. So it's sunk down through the top 2 layers, but it's sitting there in the washing up liquid. Next, I have a slice of banana. Now, banana has got skin around it, so quite a thick skin. It's quite a thick, chewy kind of fruit, and so it's also relatively heavy. I've cut a chunk that's about the same size as the date, so I want you to have a quick think. What do you think is going to happen with the banana? We go 3, 2, 1. And the banana, let me just turn it around so you can see a bit better. The banana's right here. Oh, spinning around. There's the banana. It's sunk through the oil, but it's floating on top of the water. Right. Final thing I have a piece of apple. So again, I've cut a piece of apple into a chunk about the same size as the date, about the same size as the piece of banana, just to keep our little experiment here fair. And I'm going to drop this in as well. Now, apples have got a very thin skin compared to the banana, and also there's actually quite a lot of air inside an apple, so it's actually not very heavy at all. So I want you to have a think about what's going to happen with this one, and we're going to go 3, 2, 1. And the apple there is floating on top of the oil. So I've got a stone that sank all the way to the bottom. I've got a date that's floating on top of golden syrup. I have a piece of banana that's floating in the water, and I've got a piece of apple floating on top of the oil along with the polystyrene ball. So we've seen a number of different interesting aspects of floating and sinking happening in just this glass here. So I'm going to ask you to have another think and another discussion in your class. And hopefully some of that information will be useful clues for you. But I want you to just think, how were we able to stack liquids in this way in the first place? How can we get the liquids sitting on top of each other? So have another discussion in your class. And welcome back. I can see you've had some fantastic discussions. For one thing, I'm going to say that Lily at Haddington Prep has said, for example, that some liquids are thicker than others. Miss Atkins' class is the same kind of thing. There may be because some liquids are heavier or stickier. Absolutely right. So different liquids are thicker and therefore heavier, and that might also lead them to being stickier than others. So actually our golden syrup, I said right at the start that it's very thick and gloopy. It is actually also heavier. And that means that some liquids, as Rafe says, some liquids sink and some float, and that's compared to each other. What we're seeing is that the glucose syrup is really, really heavy, and it would sink right to the bottom. That's why I put it in first. The washing up liquid is a bit less thick, it's a bit less heavy, a bit lighter, and it will float on the top of the golden syrup. So liquids themselves can float and sink comparative to each other. And the water will float on top of the washing up liquid as long as we are able to make sure they don't mix. So we had a bit of a problem with some of them mixing together. And finally, oil floats on the surface of water. The oil is very, very light in comparison to the other liquids. And this is just 4 liquids you might have lying around your house. But in actual fact, we could do this with plenty of other liquids. I've got here an even larger example. I'm just going to put this into the close-up camera, showing you what we've got here. You can see I've got here an 8-layer version of the same thing. Right at the bottom, we have golden syrup, like we had in our glass earlier. And floating on top of that is something called glycerin, which is it's a type of sugar. So again, it's quite thick and sticky. Floating on top of the glycerin, I have a layer of milk, which is nice and white in this here. Then we've got washing up liquid and water like we had in our glass before. You can see those have started to mix together a little bit. They really do like mixing together. Like Amber at Headington Prep has said that if we mix the liquids together, they won't separate. That's certainly true with some of them. The washing up liquid and the water, if we mix those together, they absolutely wouldn't separate back out again. So I have to be very careful when mixing those. Some of them won't. Like the oil and the water, even if I mix them together, they would separate out again later. They really don't like mixing, but a lot of them would mix together, like the milk and the water and the golden syrup. Probably if we shook it vigorously enough, they would stay together and not separate. Above the water, we've got oil like we had in our glass, and then even on top of oil, we've got stuff that's even lighter than oil. We have some alcohol on the top of the oil. We've colored that red just so you can see it more easily, and on top of that, we have some paraffin. So you can see we can make a nice 8 layers. It's possible to make even larger columns with even more liquids, but it gets really, really tricky to put those together. But we actually have now, we've got another liquid we're going to show you. But this liquid is very special. So we're going to be very careful. We're going to clear this away, and I'm going to have to put on some special equipment at this point because the liquid we're going to be using next is very, very cold. So to keep myself safe, first of all, I'm going to put on this apron. This is in case we spill any, so I don't get it splashed on my clothing. And then I'm going to put on a shield, just in case any of this liquid spills. I really don't want it getting in my face. And finally, I have, and this is because this liquid is so cold, I can't touch it, and I can't touch anything that has been in contact with it. So Daniel's going to bring on our special liquid here. And inside this flask, what I have is liquid nitrogen. And liquid nitrogen says that it's really, really cold. Actually, inside here, it's minus 196 degrees centigrade. And nitrogen actually makes up most of the air. And so this is liquid air, or at least a part of what makes up the air. And inside here, I can see, looking at the top, and I'll show you later, it's actually boiling. And it boils at minus 196 degrees centigrade, as I said. And basically, the way you make liquid nitrogen is you take air and you cool it down so that it condenses. Like we said earlier, that water vapor condenses into clouds. We can, in fact, condense the air itself into a liquid. And it's so cold that if I were to put more air in contact with this liquid nitrogen, it would condense down into a liquid as well. And I'm going to demonstrate that for you. I have here some air that I've previously trapped. I have a balloon that's full of air. And if I push this into our liquid nitrogen, then it's going to cool down. And that the air in here is going to turn into a liquid. Now you can see there's lots of fog coming off here as I'm cooling it down, and some of this is spilling out. I'm going to push this down. And you can probably see here the balloon is starting to deflate. There, the air inside is turning into a liquid, and obviously liquids take up less space than gases. So the balloon is deflating. And I push it down here as all that air inside it is turning into a liquid, taking up way less space. And so the balloon has turned almost completely flat. And you can see there's lots of air coming on. And I'm just going to put this down on the table because now you'll see it's warming up very rapidly. I was about to give you a warning that it might burst. And in fact, it just did that on camera. So I'm going to get a spare balloon. We're going to do it again. because I want you to see it reinflating properly. So I'm going to push this one in. And again, we watch it deflate as the air turns to liquid. And again, it's going to come out. It's all flat. And again, it might burst, so just be careful if you're a bit worried about it bursting. But you can see here that it's reinflating as that air is turning back from a liquid to a gas. You can see the balloon reinflate as if I were blowing it up. You can see I am not doing it myself. It's just, that one's popped as well. A bit less vigorously, but again, you saw that there reinflating. Now, the other thing is that I can show you some other aspects of just how cold this is, because cold, when it gets like this cold, can be actually really dangerous. I've got some flowers at the back here. I'm going to take one, bring it forward. This is a poinsettia. You don't see very many flowers in winter, and the reason for that is because flowers often don't do very well when it's really, really cold, and I'm going to show you why not. Now, outside in winter, it never gets this cold. The coldest place on Earth doesn't get anywhere close to minus 196 degrees centigrade, but I'm going to show you, if I put this flower in the liquid nitrogen, then it's going to freeze. You can see lots of fog coming off there. And now, if I just, so you can see what's happening, is it's just shattering. The water inside this flower has turned to ice, and so it's now really, really fragile. So it's fallen completely to pieces. And so that's just how dangerous. The same thing would happen to my fingers if I were to put them inside here. They would freeze completely solid. So that's why I need to take the precautions I'm taking. So what I'm going to try and do now, I teased you at the start of the snow with some fake snow. So I'm going to try and make some real snow for you now. Now, first of all, I'm going to show you on camera. You may see around the top of this container, I spilt a little bit of the liquid nitrogen earlier over the sides when I was pushing the balloon in. And you can see it's made the top of this container really, really cold. So we've got some frost already forming around the rim, and that's where water vapor from the air has come into contact with this really cold surface, and it's condensed down into a liquid, and then it's frozen into this frost. And so actually this is a small amount of snow, effectively, that's formed on the surface here. Let me just demonstrate. If I blow into the liquid nitrogen, we can see there that the water vapor in my breath is turning into mist as it contacts the cold surface here. And again, that's the tiny droplets of water turning into liquid and then freezing into snow. So there's small amounts of snow right there in the air. Now, one last thing I'm going to try and do, I'm going to cool down this frying pan. I'm going to take some of this liquid nitrogen, and I'm going to pour it into this frying pan. And you'll see one thing here. You can see when the mist clears in a moment. Possibly see there that the liquid nitrogen is boiling away. You can see it definitely is a liquid. It's sloshing around in the pan, and it's boiling away very rapidly. And that means it's cooling this pan down. When all this is boiled off, then this pan is going to be very, very cold. And what I should be able to do, I'll just pour off the last of that. This pan is so cold, I should be able to get it to turn some water into snow. I spray a water mister onto this pan. The tiny droplets are freezing into snow, and I can scrape it off and make a very small amount of snow. Right, we are very nearly done now. But all this talk of snow has once again made me feeling really cold. So like before, I just want to curl up with a book and get a candle. So I'm just going to get another candle. And bring it over here. It's going to light another candle to make me think warm thoughts. But this is slightly different because I'm going to do something a bit strange now. Delicious. Now, obviously, that wasn't a real candle. Please don't try this at home. It's not safe to eat real candles. This was something a little bit different. And I'm going to leave you that as our final question. What do you think might have been in that candle that enabled me to eat it and keep it safe for me? If you have any thoughts, you can post them in the live chat now. Or you can email them, tell your teacher and email them to us later. Teachers, if you want to know exactly what we did, if you contact us, if you give us contact details via our email address at schools@scienceoxford.com, or tell us, if you've already got your email address, tell us in the live chat that you want that information. We can send a resource to you, letting you know what we did here and how you can repeat it yourself. I'd like to say thank you all of you for having watched me, and I'll leave you with that question. You can contact us, visit our website. You can contact us on social media if you'd like, and I will leave you that question. Thank you. Goodbye.